All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the AWD1100 Programming Fundamentals with C# class, I've been doing a series of video presentations based on the PowerPoint slides for the text. I'm not going to be going over these presentations in class, rather I'm putting them out on my YouTube channel and I'll give everybody access to them. So far I've done Chapter 1, how to get started with Visual Studio, and Chapter 2, how to design a Windows Forms app. Not only did I do the same app using a Windows Form, but I also did it as a console app. So that brings us to Chapter 3, how to code and test a Windows Forms application. So that's what I'm going to do right now. All right, so with that said, let me jump into it. As always, with this being a Muroc textbook, it's going to start after our cover page here with our applied objectives and our knowledge objectives. So if you look in here, they want to make sure we know how to code and test an application, how to work with indentations and comments. Some of this stuff I've already shown you. Talk about the help features, and then describe some terminology. Things like class, object, etc. You can read them yourselves there. Describe how an application responds to events. I'm not going to really cover the snippets, but we'll talk about different kinds of errors, those being syntax errors versus runtime errors. And we'll even mention another kind, which are logic errors. Differentiate between testing and debugging, and talk about data tips. All right, so with that said, this is the program we had done earlier. A form object and its 10 control object. So this is an object. So that's number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have one form object here. We have, which is our form, 4 label objects, one that says subtotal, one that says discount percent, one that says discount amount, and one that says total. We have 4 text box objects here, 3 of which, the bottom 3, are read-only, meaning that we cannot write to them directly. 1 is not, which means we can. And we have 2 button objects, a calculate button and an exit button. And if you remember in mine, I also put in a clear button. So each one of those things that you see is an object. And as it says, an object is a self-contained unit, like a form or a control that combines the code and the data. And that's what it is. So with every one of these things has a graphical portion, and it also has potentially code associated with it. And that's what they're talking about here. Now, C# is what's called an object-oriented programming language. With an object-oriented programming language, you work with what are called classes. And a class is like a blueprint. So imagine that we were having this class in an actual classroom. And across the street from our classroom was a big tract of land with, I don't know, let's say 200 acres on it. And so a developer comes in and buys those 200 acres and plans to put 100 houses on there. Each house will take up an acre, and with the other 100 acres there'll be roads and whatever, maybe a park, doesn't matter. But if those 100 houses that we're going to make, imagine that we had 5 house plans. So we're going to build house 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, etc. Each one of those house plans or blueprints would be like a class. Each instance of the house that you build with that class would be an object. In the same way, this is a text box object that's part of the text box class. So is this, and this, and this. This is a form object that's part of the form class. These are label objects that are part of the label class, and these are button objects that are part of the button class. So an object is an instance of a class. The act of creating an object from a class is called instantiating or instantiation. All right? You can make more than one object from a single class, just like we've got more than one text box, we've got more than one label, and we've got more than one button. All right, the things that make each object rather unique are their properties. So for instance, think of a if we created a class called human being, and we said that each human being would have a height, a weight, an eye color, a hair color, and a gender. Let's just say I'm making all these up. Well, we could have hundreds of people, and each one could have their own height, their own weight, their own gender, etc. Those are the properties. And if we said that each person can eat and drink and sleep, those are the methods. So properties are characteristics of an object, and methods are behaviors or operations that an object performs. Events, as it says, are signals that tells it something has happened and you've got to do something. For instance, when you click a button, that's a button click event. All right, the different properties, methods, and events, as it says, they're the members of the object. If you make two instances of the same class, they all have the same properties, methods, and events, but the values assigned to the properties can be different for each one. When you use the C# form designer, as it says here, Visual Studio will generate some code for you automatically. When you add controls to a form, again, Visual Studio will generate some code for you automatically. All right, so some of the stuff when you're doing this, you'll have to add, and some of the stuff will be added for you. All right, it says here a member list in the code window. Let's just hold off on that. I don't think that's that important right now. If you want to refer to this, and guess what? We've done this already. So for instance, if you take a look at these two things that are in the box there, the first one says the name of the text box, .text equals 10. So that means that that text box will have the number 10 in it. The second example says that that text box will be read-only because we've set its read-only property to true. And this is what the whole semester is going to be about. All right. Class name dot member name. So there's a class. There's an object really and a member, but you can work with classes as well. And we're going to be doing this and doing this and doing this as we go on this semester. All right. So the examples that you see on this slide here, the first one will set the focus or put the cursor on that field. The second one will allow you to close something. And you might look at the example on the bottom and say, I haven't seen anything like this. Yes, you have. We've worked with click events. All right. In fact, that's what where we've been putting all of our code. All right. And they give you some stuff in here. So in other words, when we type in, so let's go back to one of the examples that we had here. And I'm going to close this one. So let me do a file save all, which is always a good idea first. You'll probably be prompted if you forget to, but that's fine. Oh, this is the first one that we brought up, that monthly investment thing. So if I go to my calculate here and I type in txt, oh, did we not name these? I don't know. This is the first one that we made here. Yeah, there's names. So right there, that should be txt monthly investment. So if I say txt monthly investment and I put a dot in there, it's going to show me all of the different properties that this text box has. The only one we've really looked at so far has been text. That one. And if we come in there and say it equals hello there, okay, and I run the program, what you're going to see, take a look at the text box. Whoopee. Doesn't like something. I forgot my semicolon at the end. Let's try it again. And you'll notice that when I click calculate, watch what happens in here. Hello there. All right. That was a click event that made that happen. All right. And again, this may not totally be making sense, but we haven't even started the class yet. Okay, let's continue on then. The act of putting in something like this, the act of responding to a click event, is known as wiring up the click event. This right here, and don't worry if you don't know what this means. I don't know exactly what it means. But the stuff you see right here is what's happening in the system files. This is what we write. Right there. All right. I just so you know, if you hear those goofy sounds in the background, I am in the office right now, and every once in a while the printer just starts up on its own, and that's what's happening. Okay, so here's some common events. Any control can have a click event associated with it. We've only looked at buttons, but you can basically take any control and give it a click event, or a double click event for that matter. Now, with the enter and the leave, not always, but most of the time, these are associated with mouse events. So when you move your mouse and you enter something, or when you leave something. Some common form events, well, when you run the program, the form load event is run. When you close your form, when you close it, it's not closed yet, but when you close it, when it's in the act of closing, all right, the closing event takes place. After it's been closed, the closed event takes place. And there are a lot more events than these. As it says, Windows Forms applications work by responding to events. You code what are called event handlers. All right, to connect the event handler, as it says there, Visual Studio generates a statement that wires it up for you in the background. That wire it up is something more like this. And again, you don't have to worry about writing that. That's written for you. All right, an event can be an action that's initiated by a user. It can be something based on time. There's a lot of different things that can make it happen. Okay, so if I go back here, and we go back to what we had here. Okay, let me get back to here and move that over. All right, so I'm going to remove this. We don't need it. In fact, I'll just comment it out. Maybe I'll bring it back later. But if you look right now, if I go to here, there's nothing associated with the exit button. Nothing at all. This one already has something associated with it. This one does not. But notice if I double click, the name of the control, BTN exit, the event, click, and an underscore between them. The object is who made this happen, and these are any arguments that it needs. Now, the args you'll almost never use, again, unless you're working with a mouse and you want to lay out positions on a screen or whatever. So I'm going to come in here and I'm just going to say this just so you see it. I'm going to put in here something you haven't seen before, but message box dot show, and I'm going to put in here, hey, you are quitting the program. Okay, boom. And then I'll just say this dot close. And watch what happens. So when I click exit, it says, hey, you are quitting the program. When I click OK, it quits. So this was the act of me setting up the code, and I don't want you to go into these files, please. because it's an easy way to screw up a program. But if I go into my designer, someplace in here, and if it's not in the designer, let's see. Let me close the designer. And let me try to open this resx file. It is not in the resx. Well, what we'll get into, and I'm jumping ahead, and I shouldn't be doing that because I'm confusing myself and probably you as well. But we are going to learn what's going to happen underneath the hood, so to speak, in these programs when you do this stuff. No, that isn't it either. All right. So let me jump back into here. So they talk about what happens when you double click on a button. Guess what? You know that because that's what we've been doing. Now, when they call this thing here the completion list, there is what is called Intellisense that is built into this. So if I go in here and I bring up my program, all right, and let's say that I want to add another button. So I add another button here, and this will be the old dependable clear button. So it's going to be btn clear. I'm going to put the code in there. I'm going to call it clear. And I realize this is kind of hard for you to see right now. So let's pretty this up a little bit. So I'll move this over, and I'll move this down. I'll take these buttons, and I'm going to move them down here, and I'm going to make them a lot bigger. So let's make them, well, I don't know what happened there, but something, come on. Something goofy happened there, so we'll fix it. So the width on this, the size is 164.79. And so they're a lot bigger. They're a lot easier to read, so to speak. And I'll come back in here, just as we have done previously. Let's go over to our font. And again, I will set this to 18.25, easier to read. And we'll set bold to true. There, that's a lot easier to read. So let's go back to these, and let's move these. And I'm going to make the size on these bigger as well. Again, let's make them 18.25. Okay, so they got thicker. Let's make them bold. And let's set it up so that the text align will be in the center. You don't have to do any of this, but I'm just trying to make this look a little nicer. So now let's move this, and this, this, and this. Now, highlight all those and bring it down a little bit. There we go. And let's move it over. All right. And finally, let's take this and we'll move, we'll move this over as well. Okay, I'm going to make this wider. Why? You'll see why in just a second. But let's click on this. And again, we will, as we have been doing, we'll make that 18.25. I know that makes it harder to read. We'll fix it in a second. And we will bold it. So let's make this a little wider so it comes out a little easier. There we go. Move that down, and we'll move that here. There we go. Now, with just a few superficial changes, I think at least we made it look a lot nicer. All right, so let's move this. We'll move that over a bit. Why? You're going to see. Okay, so I can come back in and again, change my size to 18. Boom. And we will change, and our alignment, we will make this middle right. There we go. Now, I think personally this looks a lot nicer to the eye. Now, we don't really need these to be red, so let's make these, you'll see what I'm doing in a second. So let's come in here, and let's use a softer color. So I'm going to use a medium purple. Why? Because I'm going to go to my form here, and I'm going to change the background on that as well. And we'll make that a lighter purple. There you go. Now, you may not agree with my choice of color, and that's totally fine. But you can see with making just a few fairly superficial changes, we can make this look much more appealing. All right? So that didn't really have anything to do with anything except for the fact that this is TXT monthly investment, TXT yearly interest rate, TXT number of years, and TXT future value. All right, when I double click my clear button, and I want to move my clear button code, I want to move that up above here. Didn't have to do that, but to me, it's going to read a little nicer. So I'm going to come up here and do my TXT monthly investment dot text equals double quote TXT. What are they again? There's monthly investment. And the order in which you put these, of course, doesn't matter. TXT yearly interest rate dot text is equal to double quote TXT number of years dot text is equal to double quote, and TXT future value dot text is equal to double quote. Again, if you would like to pretty this up a little, I can tab and tab and tab and tab. And when I get done, I can say TXT monthly investment dot focus. Now, what did I just do? It's easiest to show you. So I'm going to run this, put something in here, and in here, and in here, and in here. Now, when I click clear, what I have wired up to this button is to clear what's in here out, to clear what's in here out, to clear what is in here out, and to clear what in here is in there out. That's these first 4 lines. Then I told it to go back to this line and put the cursor there. So let's leave our mouse right here and click clear and see what happens. They all cleared, and you can see what happens. So I wired up that button so that it would do what I wanted it to do. Hopefully that makes at least a little bit of sense to you. So they give their example in here for this order form, and there's nothing wrong with the example that's in here. I'm not going to go through it, though. I already did one for you rather than using their example. I did one where I used those grades because I thought it would be easier for everyone to understand. Okay? All right, so like I said, I'm not going to go through that code. You can look at it on your own. You should have a working copy of that code anyway. Coding rules: use spaces to separate the words in each statement. So in other words, if I come in here, let's go back to here. If I had done this, notice it's not giving me an error, but it's harder to read, it's harder to look at. So by taking that and putting it like this, it makes it much easier to read. All right? Use exact capitalization. This language is one of many that you'll learn at Rankin. That is what's known as a case-sensitive language. End each statement with a semicolon. What happens if you don't? So I'm going to leave that semicolon off. All right, let me stop my program run. And now notice I've got an error. If I double click on the error, it shows me right where the error is. That's a syntax error. I broke the rules of the language, which say that every executable statement must end with a semicolon. So a syntax error is an error in the rules of the language. All right? You can have a runtime error. So I'm just going to come in here. I'm going to purposely put an error in here just so you see it. I'm going to say here, int x equals 23, int y equals 0, int z equals x divided by y. 23 divided by 0. It's going to give me an error, but not until I click the calculate button. So the program now is fat and happy. It has no problem with anything we're doing. But when I click the calculate button, it's going to attempt to divide by 0, and it's going to say, I don't know how to do that. So it's giving me an error that says it's a divide by 0 exception. I did something I wasn't supposed to do. And what you will learn throughout the semester is how to get over that, fix that. All right? So that's a runtime error. There's also what's called a logic error. And with a logic error, I'm going to put a different number here. And 23 and 15. Okay? And I'm going to say it equals x. I want to say z equals x plus y. All right? So z equals x plus y, and then I'm going to say message box dot show, and I'm just going to put in here z equals plus z dot toString. Okay? All I want it to do, if this works, this should say z equals 38, if it works. Z equals 38. Good. But now let's say I did this, but instead of putting a plus here, I accidentally put in a minus. And instead of saying z equals, I'm going to say in here x plus, or 23 plus 15 equals. All right, well, you're going to look at this, and you're going to know right away that there's a problem. Because it says 23 plus 15 equals 8. Well, that isn't right, because I accidentally put a minus there instead of a plus sign. If I change it to a plus sign, it's now correct. But when you mean to do A and you accidentally do B and you get the wrong result, and if the error, well, that's goofed up. That particular error, okay, so let's see. Nope, that shouldn't be equal. That should be plus. There we go. That's an error in logic. And those are the hardest errors to find. So there we go, 23 plus 15 equals 38. Programmers very quickly get this aura of invincibility about them, where they think that, geez, I didn't make that error. Well, yeah, you did. I do it all the time. We all do it all the time. Okay. All right, let's continue on then. It says the code editor and error list. Well, that's the stuff that you see down here. You've already seen that. I've shown you examples of that before. Now here they're trying to show a readable style. You can see how it's spaced out. It looks pretty nice, as opposed to this. All right, and this is all readable. That's readable and that's readable. But look at this. That'll work. It'll still work. The problem is it's very hard to read. Now internally, the computer itself takes something that you write that looks like this and converts it into more of something that looks like this. The computer doesn't care about blank spaces. It doesn't care about tabs. It doesn't care about aesthetics. It just cares about taking your code and running it through and giving you, ideally, the answers you're looking for. So you should use indentations and extra spaces to align statements, to separate words, etc. It says as you enter code in the code editor, Visual Studio automatically adjusts the formatting by default. You can override that. So again, notice here when I did this, if I come through here and say int a, and I want to put a bunch of blank spaces in here, equals, and I want to say here z divided by x. Now notice as soon as I hit the semicolon, it reformats it. If I did want those, I could still go back in there and manually put that in. But there's a lot of formatting that goes on by the system. Comments, there's two types of comment, really three types, but only two that we'll care about for right now. The first is, this is a single line comment. So I will put in here, forget what's there, and I'm going to change this to single line comment. If I want to put a comment over multiple lines, I start it with a /* and I end it with a //. So this would be a multiple line comment. Now, I just want to show you something. Let's see if I've got it in here. It looks like I don't. Yes, I do. If you look up here, there's a couple different things that are up here. We'll look at these more in depth in class. But sometimes you might want to go and take a whole bunch of code and comment it out at once, quickly. So if I highlight it all and I click over here, notice how it commented everything out. I can click the one next to it and uncomment everything. We'll go over that in class, so don't worry about it if that doesn't make sense to you right now. All right. So here's a readable code with comments. This is often referred to as a prologue because it's explaining what's going on. So comments are, it does not make the program run any faster. In fact, it actually may slow it down a little bit. Comments are ignored by the system itself, but they provide internal program documentation. And I already showed you a single line comment, // meaning everything to the right of that is commented out, and a multi-line comment, which starts with /* and it ends with //. All right. So they show you in here kind of what I just showed you, how you can comment out lines with the buttons that are in there, etc. All right. You can also take your code, and sometimes your code gets really long. So for instance, if I decide that I don't want to show everything that's in here, so I don't want to show, for example, this routine, because I'm not going to do anything with it, I can click that minus sign and see how it goes away. If I click the plus sign, it comes back again. But if all I want to see is this, calculate, I can take all the other stuff and, for lack of better words, kind of hide it. Makes it much easier when you're working with code. Some people like that. Some people don't like it. I don't use it very often, but it's a matter of personal preference. All right. Now, these completion things and some of these snippets, I'm not going to go over those because adding extra stuff or having the system write a lot of stuff for you is fine once you know what you're doing. And you're learning right now what you should be doing. So I'm going to hold off on that and on this snippet and on these options, etc. I'm going to hold off on all this stuff. All right. How to test a project. As it says, you should test the user interface to make sure it looks the way it should. You should test with valid data to make sure the program reacts the way it should. You should test with invalid data and something that isn't expected to make sure that your program can handle it. All right. Finally, just so you know, and I'm going to say this quickly, when you run a program, you can be in one of three what are called modes. Right now, I'm writing code, and I'm literally in what's called design mode. If I run my program, so if I run this, I am now in run mode. All right, and to get out of run mode, I can either click exit here, or I can click this little red square. But I can also do what's called I can put in here what's called a breakpoint. We'll have a whole chapter on this later. But if I go into this gray area that's in here, it's called a gutter area. And if I click, that put in a breakpoint. Why should you care? Because when I run the program and I click the calculate button, now I'm in the third of these three modes. I'm in what's called break mode. And you'll notice if I put my mouse here, I can put it in by Z and it says 38. I can put it by X and it says 23. I can put it by Y and it'll say 15. So I can be in either design mode as I'm writing my program, run mode when I'm running my program, or break mode when I'm telling the program to stop because there's something I want to check there. To get rid of this breakpoint, I just click on it again. So I click on it to create it. I click on it again to remove it. Okay? And that's it for the chapter. So when I come back next, we will continue on with our journey, so to speak, here. And we're going to be jumping into, so we've now finished all of section 1. So the next thing to do, as you'd probably guess, is section 2. So I'll be back with chapter 4, how to work with numeric and string data, shortly.